Hello, I'm going to present a study called Air Temperature Influence on Hot and Cold Water Consumption in Dwellings. Countries around the globe are making efforts towards decarbonized societies. This is being performed namely by taking actions to reduce energy consumption and to increase the share of renewable energy sources at the building stock level. Understanding domestic hot water consumption drivers is a key requirement for optimizing the design of innovative control strategies based on consumption patterns and the design of solar thermal hot water systems, as well as to help develop solar thermal incentive programs. In this regard, the purpose of this study is to analyze the influence of air temperature on residential hot and cold water consumption, in order to contribute for the knowledge on the behavior of domestic hot water consumption. To that end, in this study, the influence of air temperature on domestic hot and cold water consumption in two climatic distinct countries, Belgium and Portugal, has been analyzed. The dataset from Belgium, case study 1, consists in monthly consumption records of cold and hot water in 9,200 apartments from 480 buildings. The water consumption was measured continuously for 1 to 3 years in each apartment in the period between 2008 and 2012, and the disaggregation per device is unknown. For case study 2, the dataset from Portugal, we have data of cold and hot water in a bathroom recorded every 3 seconds. The water consumption was measured continuously for 163 days in the period between 2018 and 2019, and water consumption is disaggregated by appliance for the total hot and cold water, respectively. In case 1, water is heated at the level of the building. For this reason, metering exists for both cold and hot water. These are the records used in this study. But for case study 2, water is heated at the dwelling level with a gas-fired boiler, and thus metering only exists for cold water. For this reason, high-resolution records are obtained for this study. In addition, this study uses data from weather stations in Belgium and Portugal. In the Belgian case study, the initial sample comprised records from more than 10,300 apartments spread over nearly 500 buildings. However, the dataset was subject to a cleaning procedure to remove the cases with lack of cold or hot water measurements, less than 1 year of records, and incompatible hot and cold measurement dates. The cleaned dataset was reduced to 9,200 apartments, with the spatial distribution represented in the graph being 64% located in Brussels, 17% in Wallonia, and 90% in Flanders. In the Portuguese case study, data acquisition was performed through 2 ways. The first one, monitoring water consumption, and this was performed with the help of an ultrasonic flow meter connected to 2 different sensors that are here, that measured simultaneously the cold and the hot water consumed in the bathroom. And the second way was through voluntary water consumption track that consisted on the voluntary filling of a questionnaire where the user identified the appliance used and the time of use. Connecting the monitored water consumption data with the voluntary water consumption track in the Portuguese case study allowed to identify the specific water consumption pattern associated to each bathroom appliance and disaggregate the water consumption by appliance for the total, the hot, and the cold water consumed. Since the consumption of hot water In the other appliances was marginal, this study focuses only on data from the shower head. In fact, looking at here, wash basing hot water consumption represents only 4%, comparing to 96% for the shower head. Regarding the Belgian study, this figure presents the evolution of the relative daily water consumption per month and air temperature. It should be noticed that the relative consumption is given by the daily water consumption in month I of year J over the average daily water consumption in year J. This is done in order to compare months with different number of days. It is observed a slight seasonal variation on the total water consumption, with a decrease in summer months, most probably owing to reduced occupation due to vacations, but the hot water consumption shows by far the most marked pattern. The decrease in hot water consumption in the summer months results from both the decrease in total water consumption and, particularly, the shift towards using a large proportion of cold water. In fact, in another study was observed the seasonal variation of the mean monthly domestic cold water temperature in the city of Brussels, between 3 Celsius degrees in February and 17.5 Celsius degrees in July and August, as well as a direct correlation between the cold water temperature and its consumption, since in summer less hot water is used compared to winter, because the temperature of the cold water is higher. In this regard, a higher proportion of cold water is needed in relation to hot water to reach the needed volume at the same shower temperature. This proposition assumes that individuals take showers at constant temperature during the whole year. The Pearson correlation between the temperature and the cold and hot water consumption was 0.93 and 0.97, considering that it was done for the average year represented in the figure. Analyzing the proportion of cold and hot water consumption, which is given by cold or hot water consumption divided by the total water consumption, it is observed the dependence on air temperature in these two graphs. The absolute value of the Pearson correlation in both cases is 0.88, but for the hot water the signal is negative, showing that for warmer months that the hot water has lower consumption. On the other hand, for the Portuguese case study, the proportion of cold and hot water consumption is observed to have higher variability than for the Belgian case study, since the data is presented on a daily basis, not being smoothed by the monthly average. Nevertheless, the dependence on air temperature is also observed. The absolute value of the Pearson correlation in both cases is 0.7, although for the hot water the signal is negative, as already observed for the Belgian case study. In conclusion, this study analyzes data from two very distinct case studies. The Belgian case study captures the overall cold and hot water consumption pattern at a monthly time scale of a large sample of buildings. On the other hand, the Portuguese case study uses high-resolution records of cold and hot water consumption on a bathroom of a single dwelling. But despite the stringent differences, a similar and strong correlation, Pearson correlation over 0.7, between cold and hot water consumption and air temperature is found in both cases. So in both, is observed that the cold water consumption has a positive correlation with the temperature, while the hot water is negative. It is also observed that for the Belgian case study, an increase of 12 Celsius degrees in air temperature corresponds to a decrease of 8% on the proportion of hot water consumption, but to a decrease of 30% for the Portuguese case study. This indicates that it is not only the magnitude of temperature variation, but also the range of temperatures driving the hot water consumption. Lastly, it should be noticed that part of the analysis was performed in the framework of the project WALL-FIT Narrowband Internet of Things. Thank you for your attention.